Okay, that's a good sign. All right. So can you guys all see my screen, or can you folks all see my screen?
Yes.
Okay, awesome. So my name's Leila. I'm a backend engineer at Coho Financial. So we're a fintech company striving to find better financial solutions for Canadians. Our tech team is approximately 100 devs and growing. So I think actually we are hiring. I didn't come off mute earlier, but there are potentially some positions. I don't know exactly which ones, but we are hiring. And Ray and I are backend engineers on that team. So I work predominantly in the risk domain at Coho. So I do things like fraud prevention, risk management, know your customer. I work on that area of the systems. And my background previously was still in finance. I worked for a company called ATB Financial here in the prairies. I live in Alberta, in Edmonton, Alberta, Canada. So previously I was working there using Node.js, React.js, and then earlier in my career, I've dabbled in Java and C# and .NET stuff. So I'm very happy to be using Go in the last few years. It's been a great learning experience, and I've learned a ton of things, and I'm most excited today about the newest feature, or one of the newest features, which we are here to talk about today, and that's native fuzzing. So yeah, that's a bit about me. I'll pass it over to Ray so she can introduce herself.
Thank you so much, Leila. Hello, everyone. Thanks for having us this evening. My name is Rayhaneh. I also work at Coho, and yes, we do hire across the board for our positions all the time. We are a fully remote company, and we hire from all American time zones. So currently at Coho, I'm part of the enterprise team. It's a relatively new team. Our responsibility is to maintain and develop our public API. We basically provide banking as a service using this API for a few Canadian institutions. Leila and I also have been organizing events as part of the Women Who Go Toronto organizer team for the past year and a half. And this presentation is actually one of our own presentations for that group. And we thought it's shared with you here tonight. The logo on the left is our Gopher friend Meg. It's designed by one of our friends, Ellen Chiang. The inspiration behind it comes from the well-known photo of Margaret Hamilton. If you know her, she was standing beside her team's Tower of Code for the Apollo project. And behind Meg is the Toronto City Hall. That's it about me and Women Who Go Toronto. I'm going to pass this off to Leila so that she can start this off.
All right, awesome. Yeah, so to get us started, I thought we could maybe dive into a small example just to get us thinking about what fuzzing exactly is. So consider this function here. What it does is takes two slices of bytes and compares them element by element to determine if they're equal to one another. So nothing too convoluted happening here, but I can tell you there is in fact a bug hiding in the code somewhere here. And perhaps some of you might notice it already. So naturally, what do? We write some tests. So let's write some tests for this function. Here I'm just setting up my mocks. I have my first mock here will equal to one another. 1, 2, 3. The second mock will also equal. These slices will equal to one another. Foo will not equal to bar, and then testing some special characters as well as some numeric values for the bytes. So let's run the tests, and everything passes, all is good. We also, let's say we have some integration tests as well, let's assume, and everything looks good on our end, so all our tests pass. And so naturally, what we do is we ship it off to our workflow through PR review, whatever the case may be, and it's on its way to prod. And once it's in prod, unfortunately, we realize that it panics. Well, how could this be? Because we clearly wrote our tests and we had passing tests. So if we take a closer look, we notice that if the length of slice A is larger than the length of slice B, that is in fact what causes the failure, the panic, index out of range. Because for instance, if A at element 5 has a value, B at element 5 doesn't have anything, so it panics and returns the error. So let's take a closer look at our mock data and see how we ended up missing this, because we did, in fact, test this. If we look here, we'll notice that we just so happen to write mock data with slices slices that equal the same, that are the same length and size. So it was just a miss on our part, and we just totally wrote our mock data without considering this case. And essentially the reason I ran this example by you and to get you thinking about fuzzing is kind of nicely summed up in this quote. One only sees what one looks for, and one only looks for what one knows. So this is to say that us developers and humans, we write tests under assumptions and biases. And often we only test what we can think of, and we can miss certain things. And so, of course, this was just a very simple example. And you could argue that this would have been caught in PR review. But when you have larger, bigger functions that are doing a lot more convoluting things, it could be quite hard to test everything just by mocking or just by writing tests ourselves. And so this begs the question, how can we write tests how can we test what we don't know or cannot think of? Well, enter fuzzing, and that's what we're here to talk about today. So what exactly is fuzzing? Fuzzing, in a nutshell, is continuously feeding programs with automatically generated inputs to trigger unexpected behavior. And since fuzzing is not limited to human biases or even time, really, it can try lots of different things and in hopes of breaking your programs and discovering vulnerabilities, bugs, panics, infinite loops, race conditions. It's a really good testing technique to test a lot of different areas of the code that we sometimes will not capture when we're writing our own tests. So I'd like to talk about just a few benefits of fuzzing. So the first one, as we kind of saw in the example, really good at finding edge cases. And maybe that wasn't like a super edge case, but it's fine. It's good at finding cases that humans will often miss. And fuzzing engines can keep going for long periods of time and run thousands of iterations per second. So a lot faster than any human tester. And the longer you run a fuzzer, the more chances of finding issues. So there's that. And also discovering security vulnerabilities. So in fact, fuzzing actually originated in the hacking community because it's great at finding security vulnerabilities and testing your code. So watch out, if you don't fuzz, attackers might do it for you. And it also, accompanied with unit tests and integration tests, provides great insight into your software stability and increases your confidence of shipping your code. And you're more likely to have good quality code out and pushing good quality code out there. And last but not least, it removes the dependency on mock data. With fuzzing, we actually have to write our tests in a slightly different way that instead of matching all our code outputs to a specific mock data and checking that the mock data is equal to what we expect, we kind of have to check the property of the system or rely on check if certain invariants remain true in any circumstances. So it's a bit of a different mentality testing with fuzzing, but it's an additional data point accompanied with unit tests and integration tests. So next I'd like to talk about fuzzers. So the actual engine behind the fuzzing and how that all works and the different types of fuzzing engines. So fuzzing engines are essentially what controls the input generation and feeds it to your program. Fuzzing engines have evolved over time and are getting smarter and more efficient at finding issues and vulnerabilities. So let's go through a brief history of the types of different fuzzers and how they've evolved. So the very first type is, we have this lovely monkey representing the first type of this fuzzing engine, and it's random input generation. So the very first fuzzing engine, as far as we know, was a random input generation fuzzer. So what this means is it's completely random input, like no logic, rhyme, or reason. It's just taking completely wild guesses in hopes to find a bug or break something in your program or find a vulnerability. As you can imagine, this takes quite a bit of time. And, unlike this monkey, we don't want to just be sitting here trying random things for all of eternity. So we kind of have evolved our fuzzing engines to become smarter and smarter. So the next method that we've introduced into fuzzing engines is called mutation-based fuzzing. And the way this works is it actually starts with what we call a seed input that's provided by the developer to sort of help guide the fuzz engine in a certain direction so that it's not totally off the rails guessing completely random guesses. It actually has a starting point to mutate it off of the starting point. So the fuzzing engine takes this seed input and starts mutating the original input by doing things like flipping bits, deleting bits, adding, just manipulating the original input into different results. So here we see that the exclamation point got flipped to the beginning, and then the W and the H got flipped. And lastly, we have removed a bit. So we've removed the D. So this can continue going. We have just a few examples here, but this can continue going for any number of iterations. And it can get to totally different results, but at least it started with like a common starting point. So it's not totally random. And the last type of fuzzers and the last technique that's been introduced is what we call coverage guided fuzzing. And what this does is it actually leverages coverage data from your program to decide if a mutation was useful or not. So here I'll explain a little bit more how that works. So on the left, we have the fuzzing engine, which sends fuzzing input to your application, which we've represented by this fuzzy peach here. And then your application will return the coverage data, and the fuzzer will then determine, has this increased the coverage, yes or no? If so, we've deemed it a useful mutation, and that means we'd like to save it so that we could base our future mutations off of this. If not, we just delete it as it did not provide any value. So in other words, if an input or a fuzzing input has reached new areas of the code, if we're getting deeper into the program with our inputs, we find that useful and we save it. So the way that the fuzzing engine saves useful mutations is with what we call the corpus, which is basically a file that accumulates all interesting inputs, and it's shared across fuzzing runs. So it grows over time and it gets smarter and smarter as you continue to fuzz more and more things. So that's just kind of a brief overview of what fuzzing is in general and a history of how it came about and how it evolved. And now I'll pass it over to Ray to get us going on fuzzing specifically in Go.
Thanks, Leila. So in this section, I want to first talk about fuzzing in Go, and then we'll go through an example together and see how we can write one, like a fuzz test in Go now. So fuzzing has been part of the Go community for at least a couple of years, as far as I can tell. You can use the community build packages to write fuzz tests for your Go program. One popular package that is out there is Dmitry Vyukov's Go fuzz package, which was used to find a lot of bugs in the standard library itself. Back in February 2017, a proposal was filed on the Go GitHub repository. They mentioned in their proposal that, yeah, we have packages like Go Fuzz, but writing Go fuzz test is not easy as like writing any other types of tests in Go. And they proposed that this like fuzzing should be like native part of the Go program, Go standard library. So after like a lot of back and forth and discussions, which resulted in like a prototype and a bunch of other amazing work that some people did, finally back in 2021, the Go team picked up this idea of adding fuzzing to the standard library. Katie Hockman wrote the design draft, and development started after that. And now we have Go 118 that has like the first implementation of fuzzing in Go. So Leila walked you through how next slide, please, Leila. Thanks. So Leila walked you through how like a fuzzing engine works from like a high-level standpoint. Here, I want to focus on like a little bit more details about how this works in Go. This part of the presentation is based on an article published by Jay Conrad, who himself worked on building fuzzing into Go's standard library. So all the credit goes to him. Of course, you don't necessarily need to know about any of these if you just want to write the Go Fuzz test. But when we read this article, we found it interesting. So we kind of summarize it here for you. There are a lot more details. If you're interested, you can check out the article. It has like amazing explanation. So now, what happens when we run a fuzz test? So the first thing that happens, GoTest compiles the test executable with some additional coverage instrumentation that is used during fuzzing to find those interesting cases that increase coverage. So Go kind of uses like a coverage-based fuzzing technique. Now, each one of the workers have the test binary. We basically, what happens is there's a coordinator process that spins up a bunch of workers, and these workers, the coordinator passes the test binary to each one of these workers. So for the sake of simplicity, we are basically showing two workers here, but they can be more than that. These workers are the ones that actually do the fuzzing part, the fuzzing test. So each worker then has a test binary. The coordinator also gives the worker an input from the seed corpus. Leila briefly talked about the corpus. This input is basically what the person who wrote the test. These are the interesting inputs that the developer, the person who wrote the test, set up. These are being used to start the fuzzing process. Each worker uses these input files, the input values with the test binary to run that test once, and it gets back a coverage report and reports that coverage back to the coordinator. Now, the coordinator combines all these coverages into a combined based coverage. And at this stage, what I call the initialization process is done. Now, let's move on to the actual fuzzing part. So the coordinator has the base coverage. Each one of the workers, they have the test binary. The way it starts is that the coordinator now sends that base coverage, which is a combined coverage of like that initial run, to all the workers. So with an input that they can start off the fuzzing process. Here, next one, Leila, please. So here we only show that being sent to the one worker for just sake of simplicity, but the base coverage and the initial input is being sent to all the workers. So at this point, each worker tries to now mutate it. So mutate that initial input. So Go also uses a mutation-based fuzzing. So it's a combination of coverage based and mutation-based. So what it does, each worker has the input, that's the corpus. It tries to manipulate it like by deleting or inserting bytes, these type of things, and then call for the function that we're trying to fuzz with that input. After each call, the worker needs to check if we found an interesting case. There are two types of interesting cases. The first one is if a test failed. That has to be reported back to the coordinator. So when the coordinator receives that case that resulted in an error, the worker, before storing it as an interesting case, the worker needs to minimize it. So the worker sends that input back to a worker. It could be the same worker, it could be a different worker. Here, for the sake of simplicity, we are using a different worker. So that is sent to another worker. That worker minimizes it, returns it back to the coordinator. And now, I guess Leila got off.
But I got just spin up the screen again. I'm not sure how that happened.
Yeah, so until she's back. So we have like this process of minimization that has to happen at some point. It's basically it is probably obvious for everyone. Is trying to find a much smaller input that results in the same behavior. So in this case, since we had an error, if we had a failing case, the coordinator, when gets the minimized input back, it stores it in a specially formatted directory file in a special directory. And when that is stored, since this is the error case, the coordinator shuts down all the worker processes, and that's it. That's the end of our fuzzing process. But what if the first worker, when they tried the case, they didn't find an error. So this is the second type of interesting case. So at this point, the coordinator, the worker needs to check if this resulted in an increased coverage compared to the base coverage that it initially had. If it resulted in an increased coverage, if it didn't, that's not an interesting case. We're going to throw it out. But if it resulted in increased coverage, it will be reported back to the coordinator. And at that point, there is again a minimization process, and it is sent to a worker. That worker minimizes that interesting case. Of course, if it's not interesting one, if the coordinator compares that case with the current combined coverage array and it decides that, oh, some other worker already reported this case, that case is going to be discarded. But if it's an interesting one, it will be sent to a worker. That worker minimizes it and reports it back to the coordinator. And this is going to keep going until either we stop the person who's running the test, stop it, or an error case is found. So there's a lot more to it. I encourage you to read that article if you are interested in to know about internal workings of the fuzz engine in Go. But for tonight, Leila and I thought about an example. Next slide, please, Leila. Thanks. So since we work in fintech space, we thought we tried to think of an example that about something that we work with on a day-to-day basis. So here you can see something that is kind of like a handler for requests in a web server that you would see. You basically have a request coming, you parse that request, you try to, this is a request to create a transaction. So you create that transaction in your system and then return the created transaction. So let's look at different parts of this code that we have here. The first part is the incoming request. This is the incoming request struct. It has two fields. So there's a description, there's an amount. The amount is of type money.cat. That is not money, it is not part of the standard library. It's an external package we use. So let's look at that function and see what we have there. The first part of the function is where we unmarshal our request into that request struct we just talked about. Nothing strange here. Is very typical. Unmarshal it, we return the error, and that's about it. And then the next part of the function, we create that transaction object and we do some stuff. For example, we add it to our database or whatever. And then at the end, we return that created transaction. So there are like so many things we can test here, but for tonight, for the example here, Leila and I want to focus on this money.cat library. We basically, when we were running this test case, we wanted to know if there is a request we can send to this create function that could result in a transaction being created in our system that with an amount that we didn't expect. This money library is like our focus. This is a very powerful library. It has all sorts of, it can handle all sorts of currencies and all sorts of types. For example, all those requests, you can see there are like from the amount is of different types, and they all get parsed into a transaction with an amount of 1,200 cents at the end. That's what we want to test today. Okay, so now before looking into how to actually write tests for this specific example, let's look at some conventions. It's very, you are familiar with most of this already. So first of all, these conventions are, as you know, they're optional. They're there to identify the test files and indicate the non-production build files and these type of things. So in order to better understand what we are going to do in a fuzz test and how to write a fuzz test, we're going to compare it with unit test. So we have our create function, which is in a transaction package. It is in a file create.go. Like unit test, the fuzz test should also be in a file that ends with _test.go. The test function for unit test starts with test and a capital letter. For fuzz test, you can guess it starts with a fuzz and the capital letter afterwards. So test create and fuzz create in this case. And for unit tests, we pass a pointer to the testing.t object to this function, to this test function. And for fuzz test, you can guess it's testing. We pass a testing.f object to this function. So now let's look at that fuzz create and see what we have there. Next one, Leila. Thanks. So there are three main components here: the seed corpus, fuzz target, and fuzzing arguments. Let's see what each one means or is. The seed corpus, we already kind of talked about the seed corpus. These are like inputs that you provide when you write a test. They should basically reflect like what the inputs should be, or like what the inputs should look like as much as possible so that you get the best result out of fuzzer. So in Go, to register values to the seed corpus, we basically call the f.add object. Next slide, please, Leila. F.add, you can see at the end of the highlighted area. You can add as many values as you want. Here we are adding 5 sets of values. The next part of the fuzz target, the next part is the fuzz target, and this is basically basically the part that is going to get executed for all the entries in that seed corpus and any value that gets generated and gets mutated during fuzzing. The fuzz target is registered by passing passing the function to the fuzzing f.fuzz function. The next part of the fuzz test function that you need to know about is the fuzzing arguments. These are basically arguments that get mutated during fuzzing. Here we have 2. They are both integers, but you can have 1, you can have many, and they can be different values. But for this case, you're going to just mutate the dollar and the cent value in an amount of an amount and pass that to our function, use that to create a request and pass it to our function. So let's now build that fuzz target. Fuzzing has, Leila briefly talked about it. Fuzzing has like a few limitations. In unit tests, you know what the expected value of the function is, and you know what you expect out of the function. So you can at the end assert if what came out of the function, what you got after you ran your test and call the function is exactly the same as like what you expected. But in fuzz test, that's not usually the case. You might want to be a little bit creative sometimes, and it sometimes needs like a change in your mindset of like what you are testing. Similar to unit tests, we can do many things. You can test many things, but let's focus on like what we have here. We will explain it here. The first part is, this case for us, it was easy to know what we expected out of the function, because we have the dollar and the cent value being mutated at each iteration, and we can basically calculate the expected amount. It's basically the dollar multiplied by 100 plus cent. So it was easy for us to know the expected value. So here we basically that calculate amount in set basically multiplies a dollar by 100 and adds the cents value to it. So the next part, we built our request, and then we call the create function to create that function. If that function returns any errors, our test is going to fail. So this part is kind of like checking a behavior. So because we don't expect this to error out at all, we are passing valid requests to it. So we are basically here testing if the function behaved the unexpected way. And then the last part is our assertion. This is where we compare the expected value with the actual value and to see if like they match. So in this specific test that we wrote here might fail because of two things. One is we have the function return an error to us. And the second, it might fail because the expected amount wasn't the actual amount that was returned from the function wasn't what Leila and I expected, wasn't the dollar multiplied by 100 plus cents. So considering that our function can only error out if we fail to unmarshal the request, we didn't expect that to happen. And we didn't actually see that happen when we ran our test, because that basically means that we are testing the unmarshaller of the standard library, which is hopefully well tested. So it didn't error out for us, but what we saw a failure in the assertion at the end. Our fuzzer managed to create a transaction that with an amount that we didn't expect. So at this point, I'm going to just pass this to Leila so that she can walk us through how to run this test and then what we found when we ran this little test here.
Yeah, awesome. Thanks, Ray. Yeah, so as Ray mentioned, we ran this test on the money library just to see what would happen and if we actually found anything with the fuzzing. And I'll just quickly show you how we ran it, what we saw in the outputs of the console, and what the different data means. So the first line that you see here is how you actually execute the fuzz test. So go test -fuzz, and then the name of the fuzz test itself. There is also some parameters that you can set. Here are some different flags that could be used to time out the fuzz test. So in this case, with this set of parameters that we're running just the default way, it'll keep going until it finds something or until it's manually stopped. So it can go on for quite some time. So a common parameter that people will pass is a timeout, and you can set that to like an hour or a day, whatever fits your criteria. But in this case, we just ran it with the default parameters, and it did in fact find something. As you can see, we have a failed case, and it's in the create_test.go. So as Ray mentioned, we're calculated the expecting amount. So that's sort of our invariant. So that's our property that should not change under any circumstances. So that's what we're always testing against. And in this case, it actually did result in something different that we weren't expecting. So that's curious to us. And we'd like to explore it a little bit more. So we can look at down here, there's the location of the actual failing case, which will show the actual fuzz arguments that were passed in to cause the failure. And so if we expand and open this file up, we'll see that it actually provided, the fuzzer provided inputs of a dollar value of 12 and a cent value of 340. Yeah. So this is already a little bit curious. So we can look into our request payload and see how that was interpreted by our program. So the request payload was of 12.340, and we expected this to be a value of $12. And mind you, these values here are in cents. So that $12 on the left there is what we expected. And the actual result was 12K. So quite a bit of a discrepancy. And the fuzzer actually found out that the money library was recognizing this as a much larger amount than what we expected in our invariant there. And we looked into it a bit deeper and found out that this is actually because of the different ways that money is treated internationally with different formats or different, I guess, ways to delimit the thousand separator. So in this case, like, as you can see, there's a couple different ways in different countries that either use a space to delimit a thousand separator, or a comma, or a point, which we often see as a decimal, like 12.34, we would interpret that as $12, but this testing library specifically interpreted it as 12K. And so that is why we fuzz, essentially. That's what fuzzing helps us discover, things that we probably wouldn't have found if we just mocked our data and if we just, mocked a determined set list of mock data and then tested that. But with our invariant testing that calculates the amount that we expect, it was able to run lots of different mutations and eventually find this one, which was quite a surprise because that's pretty huge difference in money. And don't worry, this did not actually happen to us or at all. This was just something that me and Ray were testing like as an experiment. So if you bank with Coho, don't worry. It's just your $12 won't magically turn into 12K. But nonetheless, I hope this was kind of a comprehensive overview of fuzzing, and hopefully the example helped piece things together. And last but not least, we encourage you folks to fuzz yourself and go try it out. And we maybe have time for questions. I'm not sure how much time we will have left, but thank you so much for listening.
Yeah, thank you so much. That was awesome. Both of you, Ray and Leila, you did a really great job. We have a question in the chat. Tuer wants to know if can we also see the fuzzing test that caught the slice length bug? Was that something that you showed and she missed, or was that something that you had some results on?
At the beginning, like the first example?
We didn't show it, but I have it if you're interested. Find me on Twitter and I'll send it to you.
Yeah, we didn't include it in the presentation.
Yeah.
Okay, great. A compliment from Eugenia, which is great. Any other questions? You guys, we don't have to type it in the chat. If you would like to take yourself off mute and share, you're welcome to do that as well. But any other questions for Ray and Leila tonight? Awesome. Very, very useful.
Thanks for having us.
Yeah, thanks a lot.
Well, and please put your and also if you don't mind putting your Twitter handles in the chat in case people want to reach out and have some questions after, that would be awesome. And I'm going to, and Leila, will you turn the host over to Chris so he can get started in just a minute?
Okay.
And what I'm going to do is actually, somebody has an amazing chance of winning the 3D printer at this point. So I'm going to drop this in the chat one more time in case, nobody wants one. But you definitely have some time left to enter the raffle for that. So just wanted to throw that out there. And with that being said, Chris, I'm going to turn this over to you. And thanks for sharing with us tonight.
Cool. Thank you. Let's see. So I don't actually even necessarily need a presenter role because I switched my camera to allow me to use my OBS capture and everything. So
okay. So
it should
Leila,
be
you can just
fine.
turn it back over to me. So
yeah, I'm actually still looking for the setting. I apologize.
Oh, no problem. It's in the part. If you look in participants in the participants section, there's a more button. You'll see how to do it there.
Participants. Okay.
There you go. Thanks, Chris.
Yep. All right. So yep, I'm using OBS to present, and I will just get started then. Let me drag myself over to here. Make sure I'm not going to be revealing too much from the preview or from what the next slide is going to show. No spoilers. And cool. So I'm going to refresh and we're going to get started. I'm going to be talking about Hugo Shortcodes for the win, and I'll explain what Hugo is and who I am here in just a sec. But about me, I stream programming on Twitch. It's really fun. I do all sorts of stuff with Node, Go, Rust, Elixir. My main goal is just to build projects online and show people the process. So it's not necessarily like a teaching stream, but it's more of just a fun stream. So yep, about me, I've got that Twitch channel. I've got a Twitter. I've got a GitHub. Somewhat senior software developer, currently just chilling, hanging out, not working anywhere, enjoying it. But I am maybe interested in trying some DevRel or Dev Advocacy at some point. And I love to snowboard. So that's about all you need to know about me. What about Hugo? So if you've never heard of Hugo, it's a static site generator built with Go. For the most part, you'll just download the binary yourself and use it, and you don't necessarily need to have Go installed. But there are going to be some things where you would need to have Go set up, and we'll get into that. But mainly it ships as a binary, so you can download it from Homebrew on a Mac, Chocolatey on Windows, or Snap on Linux, or you could just go to the releases section and download the tarballs. One thing to be aware of if you go to the tarballs is that there's a difference between Hugo and Hugo Extended. Hugo Extended allows you to do like SCSS and some other things to where maybe they just wanted to keep the binary smaller. So keep that in mind if you go via the tarballs. From Homebrew, they give you Hugo Extended by default. So the first thing about Hugo, if you're getting started with it, it has no default theme. So you're going to want to grab a theme just to like see something and get it up and running. It's just important to get it going that way and just to like see something, right? Just to fiddle with it. So make sure you grab a theme of some kind. The main part about Hugo is a static site generator. So think about a static site generator for mainly like informational type sites, documentation sites, things like that, where content is king. Not necessarily a web application, but a website. So you could use it, you could have unlimited content types, maybe like a blog post or a news article or all sorts of things like a documentation page, etc. You can define your own hierarchies and schemas for these content types. And then taxonomies might be a nice, easy way of adding tags and grouping certain posts or things together. So if you're familiar with WordPress, you're actually kind of familiar with taxonomies, menus, content types, etc. It's basically like a CMS standard approach to things. The cool part is you can actually consume API-driven content too. So you can fetch something from maybe like the Star Wars API and create static HTML pages for every character from Star Wars. And it also comes with baked-in internationalization. So if you're trying to make some content, Hugo is great. And it's very fast. That's one of the important parts. If you've ever used Gatsby or some of the other static site generators out there, you can know that it could take a long time. Hugo can do thousands of pages within seconds. So that's part of the goal of it, to just be a fast static site generator, to not waste time and CPU cycles doing extra stuff. One of the main things about using Hugo is, yes, you could use Markdown in certain content types, but if you want to do templating, such as getting, headers and footers and things based around it, and maybe sidebars, whatever, and have your content be injected into a certain part of the thing, you're going to be using Go templates as like the basic syntax. They have some utility functions and everything that go into it, and you don't have to have Go installed locally for most of it, right? It'll be just the binary compiling things for you. So if you're familiar with Go template syntax, you're already good to go. One important thing to recognize about Go is that about Hugo is that it's convention over configuration, meaning it has a very specific directory structure. And based on that directory structure, it can do all sorts of cool inheritance and, load in things from the theme. And then you could override things in that theme from your own custom URL or from your own custom directories within the structure. And that's kind of where we're going to be getting into showing like how a shortcode can be created inside of Hugo. So to keep things fun and interesting here, I'm going to have some just awful jokes. I think my white noise machine is broken. It keeps making static. And because this is a talk about Hugo, we have GIFs of Hugo Weaving being very upset at these buttons. So when we want to extend Hugo, right, you can make content, HTML pages, all that stuff. If you want to do some custom functionality that Hugo doesn't necessarily ship with, there's two ways to do it. There's modules and shortcodes. Modules are powered by the Go module system, and this is where having Go installed yourself is going to be important because you would need Go greater than 1.12. If you're going to be using Versal, you need to actually set a flag for Versal to use the Go code properly. But once again, like I haven't done much with modules here, so I'm not going to be going into it much. It could be a way for me to actually make the shortcode I created and I'm going to be demonstrating actually more distributable. But for now, it's just a copy and paste kind of thing. Shortcodes are what we're actually talking about today. So there's two types of shortcodes. One thing to remember is they're only usable in content files. That would be like your markdown or just an HTML that would be injected into your layouts. You can't use these shortcodes inside of your layout files, which I find a little annoying, but it is what it is. And if you want to do stuff inside of template files, you may end up using what they call a partial. We're not going to be digging into partials today, but that might be another way that I actually extend Hugo image and make it to where other people can do what they're doing. So first thing we're going to see is there's two types of shortcodes. One would be this percentage sign based shortcode in which this stuff in here is going to get processed by the markdown engine. So this would then be bolded. This would look like a little inline code snippet. Whereas if we did the same thing in here, it would be a raw backtick and it would be a raw asterisk. Right? So the caret versus the percentage is something to realize and know about, intentionally how you want your shortcode to be consumed. So for the first time in my life, I can walk past a balloon and it doesn't stick to me. I'm absolutely ecstatic. Once again, Hugo Weaving doesn't like that. So we talked about the two types of shortcodes, right? The percentage is the content will be parsed. The caret or the angle bracket means it won't be. And there's actually some built-in shortcodes that you might want to just, check out, use them. They basically prevent you from having to duplicate a whole bunch of effort. So if you wanted to embed a GitHub gist, there's the gist shortcode. Highlighting code, right? You could actually highlight Go code, all sorts of languages, and it would create an HTML code block for you with the proper syntax highlighting and everything. You can do the same thing for Instagram posts, tweets, Vimeo, YouTube posts. And I haven't actually used Param at all, so I'm not as familiar with what that does. But there are some built-in shortcodes that can make using Hugo and making a static site just quick and easy. When you want to make a custom shortcode, this is what it might end up looking like. So here we see year, there's no content to it, so you don't need to actually close it. It's not actually an HTML element. But the cool part is this is what the internal might look like. And I'm less familiar with the now library, but I believe this is just saying the moment now we're going to create the year formatted like this. So we would probably get 2022 using the shortcode. It's a pretty small example of it, so it's not that important. But the main idea is that you can have a shortcode actually do a bunch of logic for you without having to duplicate that effort all over the place. So here we go. Here's another. A sweater I bought was picking up static electricity, so I returned it to the store. They gave me another one free of charge. All right, so let's actually dig into the shortcode I made that kind of inspired this talk. It's called Hugo Image. It's inspired by Gatsby Image, and I've written another one called Scully Image. Scully is a static site generator built on top of Angular. Gatsby is a static site generator built on top of React. And all it's going to do is create a placeholder image for us Here in Hugo, it's going to use either the blur up technique or the pixelated technique. So as an example, basically the blur up technique would say, let's say I have a giant image. It's going to resize that image to very small. And then in the HTML, we're going to use CSS to actually make it the same size as it was. And it would look awful, but you apply a CSS blur filter to it and it looks fine. And it's a nice way of just shipping less data to the user, right? So it's pretty important, right? Why would we want to do this? Well, it's faster page loads, it's less initial data over the wire, and we can actually use intersection observer to lazy load images like as we get to them, so the user doesn't have to waste bandwidth on something they're not even going to look at. Now you might ask, could we use the loading equals lazy HTML attribute on images? You could, but it's not enabled in Safari by default in desktop or mobile. And it also doesn't give us anything in place of the image, right? It's just an empty space until the image loads. So because of that, I think there's still value to something like Hugo image, Gatsby image, et cetera, right? And we're going to be using intersection observer instead to do the lazy loading itself. So what would usage of our shortcode look like, right? This is a custom shortcode we made, and we're going to be passing a named parameter to it, right? So that source equals this. We're going to dig into parameters a bit more here in a minute, but keep in mind that if I opted out of doing source equals, we could do a positional parameter. And that would just mean the first param passed to it, we would then access via the index of parameters later to pass this data and manipulate it. We have 3 different ways of using this though. And we're going to dig into why we have to maybe differentiate these. But for the most part, we can do a remote image, right? So anything on any page that has just an HTTP or HTTPS prefix or scheme, or we could do local assets. So one would be a global resource. That might be something living in your top level assets folder, maybe a place where like your icons live or things like that. And that would be something that you want accessible from all pages. But you can also do a page or content resource that would live actually next to your markdown. So it's a good way of making sure that you don't have a giant assets folder filled with thousands of images when you're trying to find one just for like the one content post you're doing. So yep, pretty cool, nice, easy usage. And we're going to dig into the configuration of that. So we saw the source parameter that's required. And then pixel height, pixel width, these are actually used to prevent layout shift. If you've ever been on a website and things just start moving around as stuff like loads in, that's a terrible user experience, isn't it? So instead, we can use pixel height and width to inform our generation of how big that image should be. And then we'll use CSS to put that into the page at that size. Keep in mind that we can actually use the image's size of the full size image just because Hugo is aware of that at build time. So it can grab the full size image's height and width. So that's why these are optional. No matter what, we still need the values to prevent layout shift, but we can actually just use the image's size itself, which is pretty cool. And then there's some other configuration. We saw resource type as global or page. And then we also see preloader type, which is the blurred or pixelated. So a little bit more info about it. There's a link to the Hugo image repo. Right now, distribution of it is just a copy and paste, so it's a little annoying. On my roadmap, I'd love to figure out how to get like the script and style snippets that we're going to have actually embeddable without extra steps. For now, you'd have to put a link to the assets within your head and at the footer as well, just to make sure that the script and style snippets load. We could theoretically put that inside of our shortcode syntax, but then we'd be duplicating those script tags every single time the shortcode gets used. And that would be really bad as well. And then another thing, I might want to look into the render hook process for Hugo. So what that means is when we have a markdown file, we can actually process that markdown file and we can use just markdown standard image syntax and use the render hook to possibly like manipulate those images programmatically without having the user actually explicitly type Hugo image. They could just do a standard markdown image and that render hook would then process it. I'm not doing that yet either, and that would be pretty fun to look into. So what do you call an electric car that isn't moving? Static. And that one's just lazy and low effort. We're making Hugo really mad at this point. Hugo leaving is very upsetting. So let's actually look at the shortcode that I made. It's really just one file besides the JS and CSS snippets. So we're just going to dig into it. That's where the file would live. And that's based on like the convention over configuration we were talking about. Based on this, Hugo is going to go look for it. And when it does a shortcode, it just does a lookup within these files. right? So it's pretty cool. One important thing is I did this just as my own personal preference. I'm trying to avoid magic strings throughout the rest of my code. And remember, this is Go template syntax. These magic strings, right? I'm going to be referencing blurred or pixelated in a few different places. I want to make sure that a typo isn't going to get me. So creating constants to avoid the magic strings is very useful. This is where the stuff that we're passing in, those parameters, actually comes into play. I call them props because I'm used to React and some of those other frameworks. But the main gist of it is we use this get function, and we just grab that source attribute or parameter that we're passing into it, and we're just going to assign these to some values. And let me double check, make sure that I'm not missing anything. Yep, someone's just saying Hugo's awesome. Perfect. So yeah, I'll try and answer some questions as we go. Just keep that in mind. So feel free to throw them out there as we're going. And then, yeah, some of these props I'm actually not using yet, like fluid max width and fluid max height. These would just be for styling, making sure that the images are responsive in a certain way, things like that. What we end up doing is when we look at these, we don't see any defaults or anything. So if I just don't pass these values, we could run into an issue. So the required for get source, we're going to run into a bunch of issues, and we'll just let that bail. But like a default value for pixel width or height or preloader type or resource type, we don't have any way of assigning that yet. So instead, we coerce those values. And you're going to see that there's actually two different ways I'm coercing these. This first one is actually less ideal. So width actually allows us to set a context and make sure that the value we're saying with is actually present. So if preloader type wasn't even passed in, this actual like line wouldn't be run and we'd be fine. But what that means is, well, if they mistyped the preloader type here, blurred would be fine. But then if they typed pixelated but added too many L's or something, everything would bail out. So instead, I would rather maybe check for an explicit value equaling, pixelated, and then assign that value separately, right? So that's what we're doing here. Instead, right, we have page and global. We only have two options. So if it's global, we know it's not page, and we just assign it to global. But either one, we have actually like coerced a default value for it. So now this is where we get into the different ways that we have to handle the image source value, because it's just a string we're passing in. We don't know where that image is just without some magic. So we have to check and see the raw image source here. We set that to the full size image path, and then later we'll assign that to the permalink value here, right? If it's an HTTP link, well, yeah, we just want to use the image.permalink, right? So the magic of it then becomes, if we are starting with HTTP, HTTPS, we just do a get remote. And boom, we have loaded the raw image source in, and we can then start manipulating that using Go's image manipulation functions. So next we see, well, if it doesn't start with HTTP, we want to go and check if it's a global resource, and then we do resources.get. This is where Hugo decides if it wants to grab it from the top level assets folder, that would be resources.get, or it would take the page reference that we have and look locally around that for the image that we're passing. When we want to actually process that image, this is where Go ships with some nice image functionality, right? So we can do a resize of it. We can also, if it's the pixelated version, instead of resizing it, we would want to do the filter. What you might notice is if it's pixelated, we're still doing the resize, but we just throw away that resized version. I would like to avoid maybe doing double processing, right? Because that's what would be happening here. And I might want to look into a better way of doing that. But here's where it actually gets tricky. If you wanted to implement some of Gatsby images like preloaders using PO trace or Squib or some of the other like SVG style like processing things, you don't actually have an ability to do that. Extending Hugo requires that you actually fork Hugo, change the functionality, and recompile the binary yourself. So that becomes a little heavy. It might be fun to experiment with actually adding an extra filter of some kind. Instead of pixelate, maybe we add PO trace, things like that. But for now, this is just what's available to us. So that's what I made this with. So the main gist is we're either going to resize it down to the very small image and then CSS blur it later, or we're going to pixelate it into this image that's the same size as the regular image, but because we've done the pixelation and how image encoding works, it's still a very small asset. And then this is where we actually can use the default image width of the thing that we fetched. So we know the size of the image because we fetched it, processed it with Hugo, and we have that raw image data. So we can populate the width and height automatically based on that, or we can pass in our own for our own layout purposes. So that was a whole bunch of just processing the parameters. This is where we actually use them, and this is still in that same file. So here, if you're not as familiar with web dev, we're basically doing a relative wrapping element. And inside of that, we're going to be doing absolutely positioned images. We start out with our preloaded image, and we have the source just set for that by default. And then we have the full size image that we're not going to actually load in the source until we get to that section. So we have to encode the full size source right here as just a data attribute. And we're going to be using JavaScript to go grab that at runtime. So we're basically just setting up our height and width to prevent the layout shift. We're setting up the 2 image tags that we're going to use to process things in and out. And then we kick into kind of how the styling does that, right? So once again, absolutely positioned. We're going to make it relative, absolutely relative to the relative element. And then the magic is we have this Hugo image blurred if it's a blur type, or Hugo image loaded then comes in after we've loaded. So we have opacity 0 on the full size image. After loaded happens, we fade it in using transition. So it's just some pretty basic CSS, but this allows us to get some pretty cool functionality for the user at runtime. And then the scripting is where a lot of the actual magic is happening for like loading and doing some of that stuff. We end up creating an intersection observer. And for every item that we're observing, we're going to loop over them. And at this point, yes, we need to look for inside of the element that we've observed. We need to then check for the full size image inside of it, add an event listener to that full size image. Because if we had done the full size image source ahead of time, these event handlers may not have actually been there, so that we wouldn't actually get the Hugo image loaded to load. So we have to make sure we're setting this source after we've attached these event listeners. Just due to timing, things like that could go wonky. And then at that point, we just get the attribute we have set the source for it, and then these 2 event handlers are going to kick off. This part down here is just setting, some of the event intersection observer logic. And then this is where we just simply query selector for all of our Hugo image wrappers and attach them to the observer. So that was a whole bunch of just junk to it. Pretty simple functionality, but it gives us something really powerful. So let me just get this joke out of the way first. I went to pick up my son the other day, and there was a static shock. I realized it's true what they say. Having kids grounds you. And Hugo is just over it. He is very upset at us. He doesn't want to hear any more puns. He is just really done with it. So real quick, let me just show you an example of how we have this going with Hugo, right? One thing I could do is inspect element, and we could set the page loading speed here in network to a slow 3G. And if we do that, right, takes a minute to load the page, sure. We see that this is what a user on a very slow 3G thing would see at first. And then as the images load in, they can preload in. So you're seeing the blur up happening, right? And up here at the top, we'll let the slow 3G do again. We saw the pixelated version as well. So that's the 2 different types that we have there, right? So this is very nice for the user. If we look at the size of these images, we're seeing 1.2 kilobytes instead of the 30 that are there for the full size images. So very useful for the user. Just makes things a lot simpler, better user experience, and saves them bandwidth if they're on mobile, which could be an issue. So I am going to dig into some of the citations and things that we're talking about, like some of the inspiration for it. First, though, you should probably go check out the Hugo docs. Those are important. It goes into much more detail than I've gone on some of this stuff. Some of the inspiration for this comes from 2015, where Facebook posted this engineering article about how they lazy loaded in this cover photo. They do some crazy shenanigans to actually squeeze it into 200 bytes, which is insane to me. But it actually works, right? They can just lazy load in the image. It looks like that after a CSS blur or some image filtering. And then as the image is fully loaded after network request, they can fade it in. So this is probably the inspiration for Gatsby image, Scully image, etc. Right? Just a whole lot of cool stuff. Another really good article is placeholder techniques. And this kind of digs into PO trace or squib right here. This is an SVG that just creates something approximately like the final image, but it's a much smaller asset because we're just, lazy loading in first just an SVG with maybe 10 items on it. This is maybe one with 100. And then later this full image can load in. So this article goes into just some of the techniques available for that, not necessarily implementations, but ideas for them. And we can see, another technique might be to use a gradient generated from colors within the image. Another technique might be to just grab a solid color. Here, they even do one where they process the image ahead of time and get a line art version of the image. And you can lazy load in and animate the line art happening, which is pretty cool. Right? This one, I think that one's a mistake, but the shapes, right? This is an example of Squib actually producing an SVG that would then turn into the Golden Gate Bridge, things like that. It's just some really cool techniques. So after they've optimized it, right, with 100 shapes or larger, you might look at like 5K or so after optimizing it, but the full size image could easily be a couple 100K. So save your user some data. And then PO trace is something like this, where it turns it into this type of SVG that you can then lazy load in after as well. And there's some other good techniques. I really recommend just reading this article. This one's a bit older as well, 2017. So yep, finally, you would probably want to take a look at Gatsby image. And because, I made the talk here, I get to plug the thing I made as well, Scully image. For the most part, these are very full featured, right? They have more placeholder styles, and they're a little more battle tested. I need to do more work for Scully image, but Gatsby image is very heavily used, and it's bulletproof. It works great. It does take a while to process some of your images though, especially if you're doing the squib technique. The reason I wanted to give this talk, and I'm really thankful for the GoSF meetup to let me do this, is there's a Hugo conference happening July 8th and 9th. Their call for presenters is still ongoing, and you could submit until the start of June, I believe. And I haven't been accepted yet, but I at least wanted to get a practice talk in beforehand, just to make sure, I work out any kinks. If you guys have any questions or anything, I can make sure I address them later in the talk as well. And yeah, hopefully I can see you guys there. It's a free online conference. So yep, sounds pretty cool. And then last but not least, what did Gandalf say to Elrond as he watched him make a basket? There's Hugo weaving again. And Hugo actually likes that one. It's great. So we nailed it. We finally had a good joke. So thank you all for letting me present. I really appreciate it. And yeah, thank you. Have a great rest of your day.
That was awesome, Chris. Thank you so much. Very, 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 very insightful, and a lot of fun as well. Anybody have any questions for Chris?
Yeah, thanks everyone. Appreciate it.
Cool, loved it. I definitely could tell that you're pretty relaxed to do this pretty often. This is it's pretty cool. How many hours do you say you do a day? Like 6 or 7?
Yeah, I stream about 6 to 7 hours a day on Twitch, just working on code, talking about it, having fun. It's great.
Okay, very cool. That's really, really great. Wow. Well, with that being said, we'll definitely get this video out there, and definitely look forward to sharing that. And a lot of people, I'm sure, are going to want to watch that as well. I'm going to go ahead and stop our recording, and